All right. So I'm at a disadvantage because we can all smell pizza. So I'm just going to get going here. A lot to cover in a short period of time. So quick intro. I work at Credit Karma as a staff engineer, leading our infrastructure services team. Pretty much managing all of our microservices, infrastructure tooling, Docker, etc. Been working at startups around San Francisco for longer than I should admit, and over that time I've seen a lot of architectures come and go, which has made me a bit of a skeptic, I suppose. But given that I'm heading a team that's working with Docker and microservices, I must be some sort of an optimist as well. So when I talk to people at meetups and so forth about what I'm working on, I was working at microservices at my previous company as well. Pretty much the first question I tend to get is, oh, you're doing microservices. Well, that's cool. We're thinking about doing microservices too. Do you think we should? And everybody's environment is different. Everybody's tech stack is different. Their organization is different. So naturally, the answer is no. No, you should not. And at that point, they either kind of shrug, wondering why I'm doing what I do, and they go off to get a beer, or we start talking about their reasons for it, which is great because then we're having a conversation. So often, they'll kind of say, especially if they're kind of young to the industry, but all these great companies are doing microservices, and so we should be doing microservices too, right? And no, the answer is no. Their problems are not the same as your problems at all. If you're asking the question, you're not doing the stuff that Google is doing, stuff that Netflix is doing, and so forth. So their reasons for doing microservices really don't apply to you. So we need to scale our app, right? We're starting to be successful, and we need to scale. So we should do microservices. Well, why do you think microservices are going to help you scale your app? If you just jump on microservices figuring that they'll scale your app, then your developers are going to look like this. They're going to be sad. Think about why you need to scale, and our microservice is really going to help because, in fact, scaling a monolith is generally pretty easy, and 90% of your scaling problems are database anyway, which is not going to be helped by microservices. You're going to introduce more moving parts, more latency, more potential problems, so it's probably not your scaling solution. But everybody says monoliths are evil, and we need to kill our monolith. Everybody I talk to says they've killed their monolith, and so we want to be next. Well, everyone is not always right, surprise. And sometimes monoliths actually make perfect sense. If you're just getting started, if you're doing a fairly standard web application, monoliths are actually much easier to run. If you don't have a DevOps team and you don't have people ready to support a distributed system, then a monolith is probably still your friend. And, I like Stonehenge as an example of a great monolith that everybody likes. But nonetheless, we hate our monolith, so we really want to get rid of it. Hating your monolith is good, so fix it. What's the problem with your monolith? Why do you hate your monolith so much? Why does it keep you up at night? Does it really require microservices and that whole ball of yarn to fix your problems and make you happier with your monolith? Well, we no longer comprehend our monolith. We don't understand how this thing works. It's been 6 years. 20% of the people who built the thing are gone. We've got pieces in there that nobody wants to touch because nobody understands it, and it kind of works, so we're not going to look at it funny. We're going to let it go. What about that? Well, we're getting somewhere now because this is actually a legitimate problem that microservices can start to fix for you. We have developers stepping on each other all the time. Deployments are taking forever. We've got all this code kind of coming into one giant monolithic code base, and nobody knows what's next. And we do a deployment, and everybody points fingers because there are 350 commits in it, and nobody knows what broke things. That's a great reason, and that's actually one of the reasons why we started to look at microservices at Credit Karma. So, leading to the question, why? We started looking at microservices evolution not quite 2 years ago, year and a half or so. At the time, we had, yes, a large PHP monolith, so it was not only a monolith, but it was PHP, so you can pity us. It was getting close to 8 years old. There were pieces of code in there that literally nobody had looked at in 5 years. We actually had someone come along saying we need to build a little bit of a search piece for this feature, and someone told me that there's some Solar somewhere in the application. Can we reuse that? And nobody had touched Solar in 5 years, and it was just running and doing its thing, but nobody really knew how it was set up anymore, and certainly didn't want to touch it, and it was running a version that was 5 years old. Deployment was really getting slow. At that time, we were just passing 200 developers at the company. Now we're past 300, 350. And with all of those people involved, trying to deploy a giant monolith gets to be quite painful. We had the tooling in place to deploy twice a week, merge everything automatically, run all the tests, figure things out. But nonetheless, you do your deployment, something breaks, nobody really understands what happened. There are literally 350 commits in the thing. It's just not encouraging the quick change and the rapid evolution that we wanted. That monolith was certainly too large for everyone to fit in their head, for anyone to understand. There were pieces that nobody understood anymore that were just sitting over there. And every change that was considered had to be really studied to figure out, if I change this thing over here, that's perfectly safe, right? Well, it's a monolith. Who else is using that code? I don't know. How do we test it? I don't know. Not a good situation. And really the upshot was that change is simply too slow. We did not want to be slowing down. We wanted to continue speeding up. And as you add more developers, you should get more work done, right? Not always. So we really wanted to shift to a model where organizationally, technically, every way, we were able to implement change more quickly, iterate, and really keep moving. And the last interesting question actually is who owns a monolith? Everyone owns a monolith, which means nobody owns a monolith. So when someone gets paged at 3 in the morning and there's a problem and they're trying to figure out who can take a look at it, well, there's that area of the code. 6 teams have touched it in the last 6 months, and we can comb through all the commits and try to figure out maybe who touched it, but it might not even be that piece. It might be some other piece that changed. Very difficult. So moving to microservices really did enable us to improve the situation, and we're still early in the process and working things out, but ultimately smaller components are much easier to understand. A team can have their service. Any team member can really understand how it works, how it's supposed to function. We moved to very clear ownership of every service, from development all the way through testing to production and after it reaches production. And that's a cultural shift that's probably a talk of its own, but everyone has embraced it really well, actually, because of the independence that really comes with it. A team owns their service, they start it in development, they implement their tests, they deploy it. One team deploys once a week, one team deploys 8 times a day. It's really up to them, but they have that freedom to move at their own speed. They can make changes as long as API contracts and things like that continue to be met. They can make changes at their own will. So microservices are certainly not free. They definitely come with a lot of added complexity operationally. The code, much simpler. The system, the opposite. So you have to make sure that trade-off is really something that you're willing to do and kind of able to tackle. So that's one reason why a company just starting out, a startup that's just getting going, jumping on the microservices on day one is crazy. It's actually going to slow you down. You really do need a team and education and process to enable the organization to manage the distributed system that you're going to end up with. Distributed systems are harder to comprehend, so you're trading understanding the code at a service level very easily with a system as a whole that's harder to understand. And the truth is that debugging monoliths is often easier. Digging down to the precise code inside a giant ball of yarn is not necessarily easier, but when you've got, as we just heard talking about NameOrD, if you've got a service that calls another service, that calls another service, and somewhere down in that stack something starts to act slowly, the culprit may be very difficult to find because your monitoring may actually first appear at one of those dependent services, and trying to figure out where the problem actually lies can be very, very difficult, and getting the right tools in place is really critical. So don't end up with a system that looks like this, where you don't know what's connected to what and why and where are things going. When we started out down this path, we started purposely very, very slow. We wanted to do a low-risk test in production. We wanted to start with something new and very small and non-critical, so if it broke, nobody really noticed. It's really tempting, though, when you're starting to think about microservices to tackle something big, because you're probably looking at some specific part of your system and thinking, this is a real pain in the ass, and we don't understand it, and we want to tear it off, and we want to run it separately. And you want to solve that big problem, but if you start with that big problem first, it's going to make you sad. You want to start with something simple before you really get going, and you want to take the time to understand what you're trying to do. So when we started out, we did not start with an orchestration framework at all, and in fact we're just starting to get an orchestration framework in place. We said, what are we trying to do? We're trying to start one microservice. We want to test something from development out to production. We want to do it simply. We want to take our time and understand what we're doing. We don't want to take 6 months to figure out how to run, 2 years ago, Mesos a marathon, or who knows what. So we wrote our own deployment tool using Salt, using Ansible. We let Supervisor run our containers on the server. We have hardware VIPs that we use to do load balancing across the instances of the service. And we ran one instance of any given service per server because they were all on the same port. So that sounds truly terrible, right? But we were using the tools that we understood at the time. We've been using Salt for a long time. So great, let's use Salt to put stuff on the servers. Ansible is very easy when you want to run something on a bunch of remote servers. Supervisor, it's there. It's there to run processes, so let's let it run Docker. I admit we're probably the only people in the world using Supervisor to run Docker containers, but it actually does work, mostly. We had hardware VIPs already, so let's do our load balancing with those. And that kind of limited us a bit to running on the same port on all the servers. That meant we could only run one instance per server, but that was okay. All we wanted was to have some servers running containers, start to send traffic to them, and start to understand how it worked. So once we understood how that worked, and we actually have 24 services running under that mechanism today on 41 Docker servers. It works, but now we have slowly brought other tools into place as we understood why we wanted them. We've been running Consul for service discovery on that cluster for a while. We brought that in place both for health checks, because Consul gives you free health checks, which is really nice, and it ended up being the backing service discovery store for Linkerd. So we just heard about Linkerd, and we use Linkerd in some interesting ways, maybe, because we do run thrift microservices. We have some REST microservices as well. We have clients in our monolith calling services in our cluster. And we did that actually by running Linkerd in a container on our Docker cluster, but Linkerd on bare metal, because we run in our own data centers. We just run Linkerd on bare metal on our old monolith servers. And that actually works to get traffic to the services, and it lets us be much more dynamic. If we need to add another instance of a service, we don't have to reconfigure our VIP and deal with all of the other pieces. A little bit more on Linkerd since it's a topic for the evening too. At Credit Karma, obviously, security is the first thing we think about whenever we do anything, before we do anything. And a couple of the nice side effects of using Linkerd is that, as Kevin mentioned, it does encrypt all the traffic. So we actually have local calls on the server, unencrypted, to Linkerd. Linkerd then finds the destination, encrypts it, sends it, and then it hits the remote Linkerd and then goes unencrypted locally to the destination service. And that also means that all the traffic goes through a single port. Rather than having to open up random ports as we bring up services, it's always reliable, always dependable, always the same one, which our networking team likes a lot and security is pretty happy with too. We're now in the process of setting up Kubernetes, so we're finally moving to orchestration. We took our time to figure out what was going to work well for us. There are a lot of orchestration tools out there now. Kubernetes seems to be winning, but it seems to be doing the job for us. We're pretty early in the process, and as one last Linkerd plug, I guess, Linkerd has been really helpful for us in migrating into Kubernetes because it allows us actually to, you didn't mention NameOrD, but Linkerd is kind of backed by this thing called NameOrD, which handles the routing and actually collects the service discovery data. And you can run multiple namers inside there. So we run one namer for our existing cluster, one namer for the Kubernetes cluster, pulling the service discovery from those two places, console and Kubernetes. And that actually has let us start to migrate services into Kubernetes fairly transparently. And it just continues to work because everything keeps going through Linkerd. So it's a really nice side effect. We're also setting up HashiCorp Vault for secrets, and just evolving this as we have figured out what we really need and what tools are out there that are going to solve our problems. So on day one, the takeaway, you don't need fancy tools. Don't try to do everything. You can actually take the stuff that you already know how to use, run some Docker containers somewhere, route some traffic to them, start to experiment with it, but you don't need to spend months learning the latest tools. And if you do, after the end of those months, there are going to be different tools that you wish you'd learned anyway. This keeps changing really, really quickly. So keep your main reasons for going to microservices in mind and focus on those, and just learn what you need to learn and then iterate from there. And take it slowly, take it carefully, but it's fun. There's an endless list of other stuff we could talk about, from security and the back pressure and timeouts and failure handling and defensive coding and writing things under the assumption that what's at the other end is maybe going to be there and maybe not, and how do you handle it properly? How do you monitor this stuff? How do you get a picture of what's going on in this distributed system and really understand kind of what's flowing where the problems are? Distributed tracing like Zipkin, all of these things. There's a ton more that goes into it, but hopefully this gives you kind of a picture of why we thought about doing this, how we approached it, the reasons we didn't have in mind for doing it, and if you've worked on microservices already, it's probably somewhat familiar to you, and if you haven't, hopefully it's useful. Thank you very much. Like everybody in San Francisco, we are of course hiring. Feel free to talk to me, and thank you very much. Questions are fine.
I'm just curious why Linkerd over Fabio?
I have looked at Fabio. I don't remember it in detail enough to really tell you why not that. I can say that one of the reasons why we favored Linkerd when we were looking at what was going on is the fact that it's built on top of Finagle. We actually have a fair number of people at Credit Karma who are ex-Twitter, who are pretty familiar with that, know what it's been through, and know that it's survived fire. So that was a pretty valuable vote of confidence for us, knowing that Linkerd is built on technology that's been doing this for a long time, and Linkerd is just making it a lot more fun to use.
Okay.
So I want to be contrarian, but with some serious.
Absolutely, yeah.
So why didn't you look at, say, doing like faster CI/CD pipelines, rewriting a monolith from the ground up, and gradually migrate services? And why do you look at other strategies to retain that approach, but do it better that work with the current engineering stack?
Yeah, we did. Yeah, we tried those things, and with an 8-year-old PHP monolith and over now 300 developers, I feel like being able to stick to a twice-a-week deployment schedule is actually not bad. Our CI/CD pipeline, well, not CD. Our CI pipeline is pretty good. We've got a lot of tools in place for merging and automatically testing and reporting errors. We've got a rollout process that's pretty safe as we deploy a new version of our monolith. So we've done a lot of that, and kind of felt like we were approaching the end of how far we could get with that. And also, even with those tools, the independence of being able to let different teams own their service, own their world from beginning to end was really, really appealing as a way for us to make sure that our just agility was continuing to grow instead of shrink.
Do you think that, can you quantify like a number of developers where beneath that level is obviously Monolith makes more sense, and above that level obviously microservices makes more sense?
I think number of developers is just one. It's one important measure, but it's one of many, I think. And I said at the beginning that everybody's organization, everybody's tech stack, everybody's problems are different, and then that's totally true. And so I'm quite sure that other companies have had different reasons for moving to microservices than ours. So it's number of developers, it's organization of your problem space, organization of how your tech kind of breaks down. At my previous startup, actually, we had a Rails monolith, and we went to microservices because we were starting to spin off additional products, but those products were based on some of the same core technology, and rather than bolting on new products onto our core monolith, going to microservices and then breaking off the shared pieces as their own services really made a whole lot more sense. And we were very small. We were only 20 developers. So yeah, it's a balance of a lot of different things, I think. All right, thank you.